In this video, we're going to practice some stoichiometry. So first, here's two weights of two compounds. We're going to do the reaction down below, but for now, go ahead and pause and find me the moles of those two compounds. All right, well, if you're back, I went ahead and found molecular masses. So sodium iodide, 1 sodium at 22.99 plus 1 iodide at 126.9 for a total of 149.89. Now, if you add up just 1 sodium and 1 iodide, that's what you get, and that's all that's in our formula. Your molecular mass is based on the formula. If you accidentally multiplied by 2, that's not part of the molecular mass. That'll come up when we use the balanced reaction later. So the molecular mass we want is just 149.89. So I've got my grams of sodium iodide. I'm trying to get to moles. So I need to get out of grams of NaI and into mole of NaI. This is why we need that molecular mass. Molecular mass is the ratio of grams to moles. 149.89. And we multiply that and divide, we will find that we have 0.2335 mole of NaI. If you want to think about sig figs for a second, I had 3, I had 5, so my final answer is going to have 3. But we don't round until we're done. We're going to use these later. But this would round to 0.234 mole. And since the top question only asks you to find moles, we'll let you see that rounding. Do the same for PbI2. Well, I need to get out of grams of lead iodide and into mole of lead 2 iodide. Molecular mass for that is 461. So it's 461.0 grams in 1 mole for 0.04338 mole of lead 2 iodide. So the weights were fairly similar, not too far off, but the moles are wildly different. That's because our molecular masses were so different. And so we don't have nearly as much lead iodide as we had sodium iodide. Again, for sig figs, 1, 2, 3, 1, 2, 3, 4, we would keep 3. If you wanted to round at this point, 0.0434 mole of lead iodide. However, we're going to end up using these values. So let's take them down to the next bit here. We have a balanced reaction. I have that 1 lead nitrate plus 2 sodium iodide makes 1 lead 2 iodide and 2 sodium nitrate. So for each of these, we're going to use one of these values and we're going to calculate out something about the other one. Let's use sodium iodide to start. 0.2335. 0.2335 mole of sodium iodide. And we want to convert this into grams of NaNO3. So I want to find how many grams of sodium nitrate are going to be made if I react 0.2335 moles of sodium iodide with 3 sig figs. Go ahead and give that a try. Go ahead and pause, see if you can calculate out those grams. All right, if you're back, well, I need to get out of one chemical and into another. I can't go from number of one to grams of another directly. I need to convert my number of sodium iodide into number of sodium nitrate. So the first step is to take my 2,335 mole of one chemical and get out of moles of that chemical and into mole of my other chemical. Basically, I have so many sodium iodides, how many sodium nitrates do I need? Well, my balanced reaction says that it is 2 and 2. So I will multiply by 2 and divide by 2. Basically, it's the same number. I need the same number of my product. So 0.2335 with 3 sig fig mole of NaNO3. If I want to get to grams, then my last step is to convert from moles to grams. To do that, I need a molecular mass. I need a ratio of moles and grams for that compound. 0.2335 mole of NaNO3. I need out of moles of NaNO3 and into grams of NaNO3. I have that up above. It was 85 grams per mole. So every 1 mole of sodium nitrate is 85.00 grams of sodium nitrate. For 19.85 grams of NaNO3, technically it was 19.848 because we only have 3 sig figs. That'll change how we round. I have 3, I have 4, I get to keep 3. So this becomes 19.8 grams of NaNO3. If all of my sodium iodide reacted to form sodium nitrate, I would make 19.8 grams of my sodium nitrate. Well, let's try it again, but this time, let's use our lead iodide. We had significantly less lead iodide, but it starts at a different part of our balance reaction. How's that going to affect our amount of product, our amount of sodium nitrate? So in this case, I have 0.04338 mole of my lead I2. And again, I want to find grams of NaNO3. Let's go ahead, take a minute, see if you can solve, again, the sodium nitrate that this time will be made if this much lead iodide was formed. All right, if you're back, well, I'm in moles of one chemical. I need to be in moles of another chemical. So 0.04338 mole of my lead iodide. I need out of moles of lead iodide and into moles of NaNO3. For that, again, it's the balanced reaction. So we go back up. This time I want to compare my lead. Well, has no coefficient out front, but that represents a 1. And a 2 for sodium nitrate. It's a 1 to 2. I need 1 lead 2 iodide for every 2 sodium nitrates. So I need 1 mole of lead iodide for every 2 mole of sodium nitrate. Result is I'll have twice as many. So I had 0.04338 moles of lead iodide. That's going to give me 0.08677 mole of NaNO3. And if we were tracking, there were 3 sig figs. So there's still 3 sig figs. This gives me my moles of sodium nitrate, which if we compare to before, up here we've got 0.233 mole of sodium nitrate, and down here we have about a third of that. So we have less sodium nitrate. Now you'll notice it's only about a third, but when we compared our lead iodide and our sodium iodide, well, almost 0.25, so almost 25 and 4-ish. This is about a fifth. I had significantly less lead iodide compared to sodium iodide. That multiplying by 2 factor meant that we got a boost to the amount of sodium nitrate. The ratio is much larger than it was for sodium iodide. As a result, well, 0.08677 mole of NaNO3. the mole of NaNO3 to grams of NaNO3, again from our molecular mass. I can add it up from periodic table. For every 1 mole of sodium nitrate, there is 85.00 grams of sodium nitrate. This is going to give me 7.375 grams of NaNO3 to 3 sig figs, so 7.38 grams of NaNO3. So this time we made substantially less, 7.4 grams versus almost 20. So what's the difference? Well, we just had more sodium iodide. There was a significant increase in sodium iodide versus lead iodide, and so when we do these conversions, we find a greater amount of the sodium nitrate was produced based on the lead iodide. A greater amount of sodium nitrate was produced based on the sodium iodide than on the lead iodide. Example, idea of this practice: find your moles, be comfortable finding a molecular mass and converting a weight of one compound into moles of that compound. And then, regardless of what you're starting with, if you know your moles of one chemical, you can use a balanced reaction to find moles of a second chemical. And so sodium iodide, if I had that many moles of sodium iodide react, it would make that many moles of sodium nitrate. Separately, we had another example where we had a certain moles of one chemical, my lead iodide, and we decided to say, well, the balanced reaction, well, it's not 1-to-1, so it gives me a different moles of my sodium nitrate, but that doesn't stop me from finding the weight of that. And so the balanced reaction gets included each time to adjust for the number that would be created, and then the molecular masses tells us the weight that number represents.